Hi, everyone. Good morning, good afternoon, or good evening, as the case may be. For me, it's bright and early in the morning. Well, it's not yet bright. It's still quite dark, but it's early in the morning. And this talk today is about Ostinato, which is a packet crafter and traffic generator. So the presentation is structured in a way in the following agenda. We'll start a bit about myself, followed by, I'll tell you a brief about story about how Ostinato started, an overview about how what Ostinato does and what it's capable of and what it can't do and what it can do. Then we'll spend most of the time doing a demo, and I'll show you various things that Ostinato can do and how you can do those. We'll talk a bit about topologies. I'll give you indicative performance about what is the max rate that Ostinato can generate, some caveats, followed by Q&A. So I'll probably take questions in between also. So please type them in the Q&A box, and Chris will help me with the Q&A at defined points in the presentation. So let's get started. So who am I? So I've been a network engineer and developer for the past 2 decades. I started my career in the telecom side with port signaling and access site signaling and network site signaling. And in fact, true story that I first learned about ethereal back then, and I wrote my first dissector then for M3UA, if I remember correctly. But I was too much of a noob and too much of imposter syndrome that I never contributed it back to the ethereal. Well, but finally we have an M3UA dissector, so nothing lost. Subsequent to that, I moved into data networking, where I worked on the L2 and L3 forwarding, also MPLS. I've dabbled a bit with ACLs and firewall in the data plane. I worked across a range of products, have written software for home CPEs, DS lamps, top of rack switches, SP, edge and core routers. That list of jobs there is my day jobs, and Juniper is where I'm currently at. But Ostinato itself is a side project which is not related to my day job. It's just something I do on the side as a passion project. So the story about how Ostinato began. So the year was 2007. I was working on a Linux data path accelerator. As we know, Linux is not built for forwarding kind of scenarios, so the performance is really quite bad. So we were trying to use flow cache principles to accelerate the Linux data path, send the first packet of a flow through the Linux, build a flow cache entry, and then send the subsequent packets through the flow cache entry, which is faster. So the question was, how do we test it? So how do we test the slow path and the fast path? How do we test the various protocols? How do we check that the invalid packets are dropped or dealt with in the manner they're supposed to? And for debugging purposes, we needed a controlled environment where we could send one packet, see that it goes through the whole path correctly, and debug if something is not working. Now, the normal answer to these questions is to use the industry standard IXIA or Spirent traffic generators. But for this project, I couldn't get access to those. I used it earlier and knew what they were capable of, and it was exactly what I needed here. But for various reasons, I couldn't get access to those for this particular project. And I couldn't find an equivalent FOSS tool at that time. Or maybe I didn't look hard enough, I don't know. But I couldn't find one. So the question then was, what do I do? How do I proceed that I can't get access to the traffic generators? In true geek fashion, I said I'll write my own. And that's how Ostinato was started. So a brief history about Ostinato. It was back in 2007, as I said, when I started hacking around and trying various experiments. I continued development in a private repo for the next 2 years. By 2010, I thought I had enough to show the world. and I did a public launch of version 0.1. And in fact, the public launch was by sending a mail to Wireshark users on April 11, 2010 about the project. Since then, in true open source fashion, I've made multiple 0.x releases with more features and bug fixes. The big 1.0 release happened in 2019. And earlier this year, I released the latest version, which is version 1.1 as of now. A brief thing about sustainability. So I've been working on the project for the past 13 plus years. I've written most of the code. As I said, it's a side project for me. I'm using my personal time and my personal resources. I have a full-time job that pays my bills. The Ostinato is open source, but for anyone who's worked around open source for a long while, especially if you've been a maintainer or a core team contributor, you know sustainability is a problem. And sustainability has many factors. It's money, time, resources, a bus factor, etc. So at least on the money front and the resources front, some of the experiments that I have tried to sustain Ostinato with is donations and pay what you want. And both of them didn't work. So the current experiment that I'm running is that the binaries or the pre-built binaries for the executables for Ostinato, there is a small token amount that you need to pay. The source code is still free. You can download and you can do a Git clone and compile and build on your own. You don't need to pay anything. But if you download the binaries from the website, you pay a small token amount to sustain the project. The reason I bring this up right now is if you're anything like me, you'd have probably already be on the Ostinato website and looking around, and you might get confused when I say it's open source and suddenly you see that if you try and download it, it asks for some money. So this is the reason why it asks for some money to download the software. You can always go to the source code and build it on your own. Okay, with that out of the way, let's talk about Ostinato itself. So what is Ostinato? So it's a packet crafter and traffic generator. And I distinguish between the two as follows. So packet crafter is something that lets you control every aspect of the packet content. So if you have used KP before, it's what I call a packet crafter. You can configure which all protocols are part of the packet, what are the packet fields for each of those protocols. So iPerf, on the other hand, is a traffic generator. At least I distinguish it as a traffic generator. You don't get control of the packet contents very much. Certainly a few fields you can change, but otherwise it's more about at what rate and what protocol, etc. So Ostinato tries to be both. And as I said, it's open source and it's cross-platform, works on Windows, Linux, and Mac OS. So what can you use it for? So you can use it to test your network devices or your network itself by generating synthetic traffic. Pcap replay, as you're aware, there are a host of use cases for Pcap replay, and Ostinato can be used for Pcap edit and replay. And I'll briefly show it to you in the demo. Any troubleshooting that you are doing and you want to generate a certain kind of traffic to localize what is happening or to find out which kind of traffic is hitting a problem, you can do that. If you're doing search study and labbing, you can use Ostinato with any of the popular labbing platforms like GNS3, EVNG, or Viral, or as it's currently known as CML. If you're teaching and learning networks, I think Ostinato is a great tool. You already probably use Wireshark and Pcaps to learn. Ostinato goes one step ahead because it lets you practice what you learn. There's nothing like trying to build your own packets, sending them out, and then you're not getting the response that you want. So you go and dig around why you didn't get the response, and then you figure out, if I change this, this is what happens. If I change that, that is what happens, and that's a great way to learn. And of course, there are many more use cases wherever you need to generate any kind of synthetic traffic, you can use Ostinato for. So what is the relationship between Wireshark and Ostinato? So Wireshark takes packets on the wire and decodes them into its protocols and fields. Ostinato takes protocols and fields, builds them into a packet, and puts them on the wire. Ergo, Ostinato is equal to Wireshark in reverse. This also makes it a very nice companion for Wireshark because it completes the loop and you can test what you want and verify it using Wireshark. On the features trend, this is a very high level overview and we'll have a demo coming up where I'll show you some of the stuff. So you can configure multiple streams. A stream is a sequence of packets and I'll show you what in the demo. On a per stream basis, you can configure rates, what rates you want, whether you want bursts or you don't want bursts, what size of bursts, the number of packets you want to send, and you also get statistics on a per stream basis. You also have real-time port statistics that you can monitor. But another big feature in Ostinato is device emulation. So typically when you use iPerf and send out packets, it's sent out from the source IP that is assigned to the interface in the OS. With Ostinato, you can actually emulate a whole host of devices which have nothing to do with what is the IP address assigned to that interface. And not only can you send packets from multiple emulated devices, those emulated devices will also respond to ARP and ping if it receives from the peers. There's a set of common protocols that is supported. Both IPv4 and IPv6 is supported, of course. You can set and edit any field of any protocol. And at each packet, you can keep varying packet fields. There are, of course, many more features that you can look at, and you will see some of them in the upcoming demo. Before we go to the demo, however, let's talk about what it cannot do. So what it doesn't have is there is no stateful support, which essentially means you can't establish a TCP connection and send traffic on the connection because it can't do a three-way handshake or populate sequence and ACK numbers based on what it receives from the peer. You can send TCP stateless. So I mean, there's nothing like TCP stateless as such. What I mean by TCP stateless here is you can fix in some values for sequence and ACK numbers and send those. For example, those are useful for when you're testing ACLs or stateless firewalls. There are some other use cases also where that might be helpful. So if stateless TCP is what you need, you could do that. What about L4 to L7 applications? Well, that depends. Again, as I said, if you need any kind of stateful support, Ostinato can't help you there. But if you just need to pump packets with certain packet contents and keep pumping them out, you could always use Ostinato for that. Okay, so it's demo time. So before I go to the demo, Chris, do we have any questions?
I do not see any questions. Nope.
Okay, let's go to the demo then. Okay, give me a minute while I set up the demo. Okay. So the demos are essentially in two categories. We'll start with the basics, and I'll show you how to use Ostinato to create packets from scratch. Then we'll look at, instead of creating packets from scratch, how to use a Pcap to import the Pcap packets, edit them, and replay them. Then we'll go to some higher level scenarios where we can do a routing test. Then we'll do an IMIX test, and then we can do an IGMP multicast test. So let's start with the basics of how to create packets from scratch. So when you open Ostinato, this is how the application looks. And let me briefly tell you about the various UI parts of it so that you can follow along. On this left side, the list, you see a list of ports. These are essentially the ports on my local machine. On the bottom is the real-time port statistics. You can monitor all the statistics like number of frames received, sent, the rates, the bytes, and so on. And then when you click on one of the ports, you see this workspace that opens up on the top right. And this is where you define your packets and streams and so on. So let's start. So we'll start. So I've chosen my Wi-Fi port here on the left side. I'm going to right click and do a new stream. That brings up this dialog box, which is chock-a-block. Let me also go through these for your benefit. You can name the stream. This doesn't have any implication on the packet that is sent out. But when you have multiple streams, it's good to know what those are. Then you have the frame length. Below that, you can select the various protocols that you'd want in your packet. For example, I'm going to select Ethernet, IPv4, UDP for this demo. Then we go to the protocol data tab, and we can now fill in the fields for each of these protocols. So as you can see, the MAC protocol already has something set up, and it says the mode is resolve, which essentially means it's going to, based on the IP addresses that you enter, it will fill in the source and destination MAC addresses. For ether type, it's already set it up as 0800 because that's the hex value for the ether type for IPv4, and that's what we have as the payload for the Ethernet. Now, if you go to IPv4, you'll see every field in the packet is available here for you to manipulate. You don't really, of course, have to set up all of them. You only need to change what you change. And those typically would mean stuff like the source and destination IP. So let's do that. So I'm going to set the source to 192.168.1.3, which is the IP address of my Wi-Fi interface. And the destination, I'm going to set it up as 192.168.1.1, which is my home router. We'll skip this variable fields tab for now. I'll come back to it later. If you go to the stream control tab, you have control on whether you want to send packets or bursts, how many of those you want to send, and at what rates do you want to send. Okay. And once you've sent all the packets, what do? Do you go to the next stream? Do you stop, or do you loop? So let's change this to, let's say 100 packets per second. And I change it to go to first. Go to first essentially meaning this is the only stream, so it will keep on repeating this stream. Then we head to packet view. So this is a Wireshark-like view, which you're very familiar with, that you can see all the protocols and packets that you've configured, and you also get to see a hex dump of what the packet will look like on the wire. Okay, we hit OK. I apply to activate my changes. Now we have too many ports here. It's going to get confusing. So let me first fix that.
While you're setting that as well, there's a question that came in. Can it create jumbo and runt frames?
You can create jumbo frames as long as your NIC allows it. You may not be able to create run frames because most drivers will pad the Ethernet up to 64.
Okay. One other
But if your
question.
NIC allows it, then, or your NIC driver allows it rather, you can send run frames. But typically most host OSs, you will not be able to send run frames.
Okay, thank you. One other question. Do you generate the checksums or offload that to the NIC?
We generate the checksums. The whole packet is pre-generated and it is not offloaded to the NIC. One primary reason we do that also is because it is cross-platform, to offload it to the NIC will require platform-specific code for each platform. So we do the NIC checksums on our own.
Thank you.
Okay, so now stuff is clear. We have only one port that you see listed here. I've hidden away all the other ports. So we're going to send 100 packets per second. And I'm going to hit transmit. And if you see here, the frame rate that is being sent out is 100. We can check that by going to Wireshark. I already have a capture that is started. And if you see, this is what we configured, 1.3 to 1.1. The default packet size was 64. And because Wireshark doesn't show the FCS, the length is shown as 60. Now, this UDP is not very interesting because the router is not going to respond to this packet. So let's try changing it to something that the router will respond to. So I'm going to go to protocol selection, go to ICMP. So instead of UDP, I'm going to now send ICMP. If I go to protocol data, I see that the ICMP type, which is sent by default, is echo request, which is what we want, which is ping request. So the router will respond with a echo reply or a ping reply. I hit OK, apply, and I start transmit again. And if I go to Wireshark, you see now we're getting responses from the router for each of the pings. Now, one thing that you will notice here is the sequence number is 0 because we haven't asked it to increment sequence numbers. So, and if you don't, it's a fixed value that gets sent in every packet. So let's fix that. I stop the transmit, open up again. Now I can change this sequence number here to some other random value. But again, it's going to send this fixed value again and again, which is not what we want. So instead of doing that, we now go to the variable fields tab, select ICMP, click on this plus icon to add a variable field, go down and select the sequence field. The mode is by default set to increment. You can change it to decrement or random, but for now, increment serves our purposes. And let's say we change it from, we want to change the value of sequence numbers from 1 to 10. I hit OK, apply. So every time you need to make a change, you need to hit apply. And I'll tell you why later on, but it tells you that by this message here and by turning your port into red to show that there are some unapplied configurations. So for now, I apply and I start transmit. And if you see now, the sequence numbers have now started incrementing from 1 to 10.
There's a question about the output on this. Can you output from Ostinato to Pcap rather than writing to wire?
So it uses the libpcap library, of course. So, and the libpcap API to write, to send packets to the NIC. but it doesn't create a Pcap and then try to replay it. It just uses the libpcap API to send the packets out. So, but was the question, can you write it to a Pcap file?
Yeah, could you write it to a Pcap file instead of directly to the wire?
Yes, you can, sorry. You right click, say save streams. By default, you'll save it in Ostinato format, but you can change it to Pcap and save it as a Pcap file. So you can directly write to file instead of generating traffic on the wire. Sure, you can do that. Okay, so that was how you create packets from scratch. Let me now go to the second part, which is the how to create packets from a Pcap file. Let me delete the stream. Now, if you right click, instead of creating new stream, which creates a packet from scratch, you go to open streams. Let me go to my desktop. I change this to Pcap, and I have an ARPStorm Pcap that I have picked up from the Wireshark wiki of sample captures. I open it up. Now, this is an interesting dialog box that you get. So if you see here, it says intelligent import. What intelligent import means is when Ostinato will read this Pcap file and import it into Ostinato, it's first going to decode it into protocols and fields, and it will use that decoded information to set up those protocols and fields in Ostinato so that you can edit them. If you don't do an intelligent import, it'll just import it as a raw hex dump. So if you want to edit it, you have to directly edit the hex. But by default, it'll do an intelligent import, which means it will decode it and use the decoded information to import it into Ostinato so that you can still see the protocols and fields and edit them conveniently. So I'm going to hit on OK. Yeah. So as you can see, we have a number of streams that have been imported, 622 of them all. So when you actually import a Pcap, each packet in the Pcap file becomes a stream. So it doesn't try to build TCP conversations or UDP conversations and build them into a stream. That's not how it works. Each packet is imported as an individual stream. So let's edit one of those to see. So yeah, the packet view is a good place. As you can see, it tells you the packet contents. If we go to protocol data, so this was the packet contents in that packet in the Pcap. These were the IP addresses that were set up. And so typically ARP will not have a payload, but in this case, looks like the Pcap has something after the ARP header. So Ostinato has just imported it as an hex dump. And if you want, you could change that as well. Okay, so we're not going to change anything. So I'm going to click on cancel. I hit apply. It says I'm already transmitting, so I need to first stop the transmit, which I will do right now. Let me also start a capture. Actually, you know what? Let me not send a unknown Pcap file on my Wi-Fi interface through which I'm connected to this session, lest something goes wrong. Let's change our port. Okay. Just give me a minute. So, okay, this is a good one. Okay, so I've changed it to an Ethernet port, which is not really connected to my internet. So we can use that. I'm just going to do the same thing that I did there. I'm going to do open streams and go to my desktop, select the file type as Pcap, select ARP-Storm, and let it import. And I click apply. Let me also change the port in Wireshark. Okay. Oh, that's the wrong port, I'm afraid. Yeah, we need the port 1. Okay. So Wireshark, actually we needed port 2 only, my bad. I thought I selected port 1 there. Again, stop. Options and click on port 2. Okay. So we have stuff imported. Let's just click on start transmit. And if I go to Wireshark, you'll see packets are transmitting. There were 622 packets. This is still incrementing, so it's still sending all of those packets. The one thing to notice here is look at the time delta. You'll see it keeps varying. The reason is that when you import a Pcap file, Ostinato will try to be true to the timing in the Pcap file. So it will try to send packets with the same timing that the original Pcap contained, right? So it says 624. That's possibly because we have some DHCP packets here. Let me apply a filter, ARP. Okay, maybe the host itself has sent some packets here. So that's why we're seeing, no, actually, it says displayed here 622 on the bottom here. So we do have 622 packets that were sent out. Now, because it's imported and broken it down into protocols and fields, if you need to change anything from the imported Pcap, you could do that. For example, let's go to the first packet. And so the target protocol IP here was .159. Let me change it to .160. Apply that. Stop, and I start again. And I transmit. So there was the first packet that we changed, and the target IP, which was .159, is now changed to 160 because we edited the imported. So we've imported a Pcap, we've edited it, and we've replayed the packet. So that finishes the basics section of Ostinato. Chris, any questions before I go to the scenarios?
Yes, you do. You have quite a few that have lined up for you. I don't know if you can see the Q&A, but I can just read these off for you if you like.
Yeah, please.
Okay, sure. So the first one, does Ostinato create packets sent, correlate packets sent with packets received? Does Ostinato correlate packets sent with packets received?
Okay, so so by default, it's just a generator. It's not going to correlate them. It depends on what you mean by correlate. So you can see the statistics here of number of frames sent and what you receive. And you can also look at stuff like packet loss, because when you're sending packets on a host like a Windows or a Mac OS, you'll have the host also sending packets. So you can actually filter those out by using something called stream statistics. But other than that, you need to be more specific about what you mean by correlation for me to be able to answer that.
Okay. There was a question, do you have server-side agents so we can quantify packet loss for VoIP video-enabled networks? You have
So
a server side
we'll take that question later on. I'll show you the routing test, etc. And based on that, I'll answer that question later.
Okay, good. I'll go ahead and leave that till later. And as far as Ostinato, what is it written in?
It's C++ with Qt as the GUI toolkit.
Okay, good. Does the intelligent Pcap import work for any protocol?
It works for all the protocols that are supported by Ostinato. If there is a protocol that Ostinato does not support, which the Pcap contains, it will import it as a hex dump.
Okay. Have you come
So when you
across
replay it, you'll still see the correct contents going out. But if you need to edit it, you'll have to edit it as hex rather than as packet fields.
Okay, sorry, I didn't mean to stomp on you there.
No problem.
Have you come across issues with importing large Pcap or PCAP-NG files? And if so, what's the limit?
So there is no limit as such. As if you do an intelligent import, it's going to do a decode, which takes a bit of time, and then the import is going to take a bit of time. But you can actually import large files. I've not seen an error as such with importing large files. It just takes a long, long time, depending on the size of your Pcap file.
Okay, good. Another one, can you show the log tab in the demo?
Okay. I'll show it to you in the, okay, I can show it to you right now. So this is just, it'll make more sense when I tell you about the architecture. So, or maybe even beyond that, it makes a sense. So let me just show you. So it just tells you what is happening. I mean, here it says, we'll talk about this reconnect later. So the port will go up connected. We are saying creating new stream. So when you click on apply, that's when all these things happen. More on that later. I mean, the primary reason for the logs tab is if there are some errors in ARP resolution or stuff like that, it'll show up here. Or if something goes bad and you need to be informed as the user, you'll see it here.
Okay, just one last one then before you continue. How's the performance? Since this is built as a free replacement for the Ixia Aspirant system, can it fill a 10 gig pipe?
More on that later. I have a slide on that.
Okay. The other ones we can hold for now.
Okay. So let's go to the demos. So we'll start with the routing test. So let's look at the diagram on the left. So let's say this is the network that we are trying to test. You'll see Ostinato at the bottom. And if you see, there are two ports on Ostinato, one on the 100 subnet and the other on the 200 subnet. And each subnet has 11 to 20, that means 10 hosts on each subnet. So what we want with this test is we want to send packets out of the 100 subnet. It will get routed through this network and come back on the 200 subnet. That means from 100.1.1.1, we probably send to 200.1.1 subnet. And we should see that aim is to verify whether this network is routing these packets correctly, right? Now, if we look at the diagram on the right, which is essentially same as the left, except the Ostinato icon is expanded. That expanded icon shows that we have two subnets, 100 and 200, each with 10 hosts. So these 10 hosts on each subnet are the hosts that Ostinato is going to emulate. So the host OS, I have not configured any of this. I'm going to configure all these emulated hosts on Ostinato itself. So it has nothing to do with your IP configuration of the interface from which you're sending these packets out. All this is done within Ostinato, and is even if your whole operating system has not assigned any IP address to that interface, all this will still work. So I've changed the right diagram slightly. For this demo purposes, instead of using 4 routers, I'm just using 1 virtual router. But the principle remains the same. We're still routing between the 100 and 200 subnets. Okay, let's get to Ostinato now. It's already stopped. Okay, so I need a different set of ports which are connected to my virtual routers. So let me select those. So this bit that I'm doing, the port reservation, is just when you have multiple people working on the same box, you can reserve ports in your particular name so that you can identify who is using which port. And the nice advantage, that side effect it has, is if you've reserved ports, you can use this view, show my reserved ports only, to filter those out so that you can remove all those extraneous ports. Okay, so we're going to start. So we'll first go to the devices tab. So we first create 10 emulated hosts on the 100 subnet. I'm going to click new device group. I'm going to give it a name, subnet 100. The name really doesn't matter. We're going to create 10 devices. IPv4 100.1.1.11. The gateway is by default set to 1.1. If you want, you can change it. But for now, it works for us because that's what I have configured on the router as well. Okay. We go to the other port, and this will be subnet 200. Again, the name doesn't matter. IPv4 200.1.1.11. Okay, I click on apply. Now we'll create our traffic stream. Say Ethernet IP UDP. We go to IP, and we say source is 101.1.11. Destination is 201.1.11. And the mode by default, if you send it like this is just a start. We'll send from .11 to .11. Let's change that. We'll say increment host by 10 counts, and increment destination host also by 10 counts. So what will happen is it will send .11 to .11, .12 to .12, .13 to .13, so on. Okay, I go to stream control. Let me send it in a loop. And apply. I'll clear the statistics and start transmitting. Let me go to Wireshark. Okay, there's too many ports for me to figure out where is it. Okay. Okay. Remove the filter. Yeah, so you can see packets are being generated .11 to .11, .12 to .12, and so on. But the rate is not interesting. Let me increase the rate. I need to stop the traffic before I can change anything. Let me change the rate to 1,000 packets per second and start transmit again. So as you can see here, the frame rate send is 1,000, and the frame receive rate on the other port is also 1,000. So we're sending 1,000 frames per second, receiving 1,000 frames per second. Let me show you on the router. It'll take a couple of seconds to update. And you can see ETH1 is receiving 1,000 frames per second and sending out 1,000 frames per second. The other thing, if we click on this and look at, let's say, the TTL in the IP header, it says 126. Let's see what was sent. What is being sent here is 127. Because the router is a hop, it's going to decrement the TTL and send. So 126 is the correct value to expect there. So we successfully done a routing test. Let me now go to do an IMIX test. So IMIX, if you're not aware, is a short for internet mix, and it's essentially packets of three different. So internet mix is essentially what is supposed to be representative of what is a typical traffic on the internet. And there are various IMIX profiles, none of them standard. Each vendor has their own IMIX profile. What simple IMIX that I'm taking here is from this wiki page. And this is the definition of that IMIX file. So it means packet size 40, that's an IP packet size. 7 of those, 4 of packet size 576 and 1 of packet size 1500. All of this are being sent in this ratio. So on the wire, the packet distribution is in that ratio, and on the byte distribution is in that ratio. Okay, so I think we're running short of time, so I'm going to quickly do this. I'm going to first stop this. So So 40 will anyway come to 64 on the wire, which is fine. We want to send 7 packets, so I'm going to change this to 7. Yeah, that's fine. I'm going to duplicate the stream twice. Change this to 576. Now 576 IP packet size will on the wire be 594. And we want to send 4 packets per second. We change that. And the third one is 1500. 1500 on the wire will become 1518. But while prepping for this demo, I discovered this VirtualBox has a problem with packet sizes more than 1504. So I'm going to keep this 1504 and packet rate as 1. Now, by default, when you send packets, 3 different streams, it will send all 7 packets of this, followed by 4 packets of this, followed by 1 packet of this. So that's not typically what we want. We want them all to be mixed together. So what we do for that is we click on port configuration, change the transmit mode from sequential to interleaved. So there is a bug there. When I do that, it clears my reservation, and so the port disappears. Let me reserve it again. Okay. So you can see average packets per second is 12 here. I'll clear all the ports and start sending. So 12 packets are being sent, 12 are being received here. So let's increase that to 1,000. Apply. And you'll see 1,000 being sent and 1,000 being received. Cool. So I'm not going to spend more time on this because I have some other things also to show you, and we're running short of time. Stop this. We quickly do multicast data and IGMP test. So let's start from scratch. I'll delete all the streams, create a new stream, Ethernet IP UDP, protocol data. I can keep this 100.1.1.11. And this time the destination will enter as a multicast IP address, which is, let's say, 239.1.1.1. And let's change this to a 1,000 packets per second. On this other side, we'll create a IGMP stream, or this will be an IGMP join. So Ethernet, IPv4, IGMP. So this will be 201.1. The client side is that. And the destination is 230, the group address, which is 239.1.1.1. We go to IGMP and we select a IGMP v2 join. Where can't I? Yeah, IGMP v2 report. And we also need to change the group address here, 239.1.1.1. Let me duplicate this. We'll create a IGMP leave as well. I change the report to a leave. The IGMP leaves are not sent to the group address. They're sent to the all multicast router address, so which is 224.0.0.2. So I have to change that as well. And I think we need to change only. We want to send only one packet. I'll change this also to send only one packet, right? So I've disabled the leave. I'm going to just send an IGMP join first. But before I send the join, let's clear the stats. Let's first start sending the multicast data. So you see 1,000 packets being sent, but nothing received on the other port because we've not yet sent the IGMP join. So I'm going to now send the IGMP join, and we see start getting 1,000 packets per second, right? Now I'm going to disable the join and enable the leave, and now I'll send the leave. Now, when I send the leave, you see we're still receiving 1,000 packets. That's because routers will typically not leave immediately. They send the IGMP query and you have to respond with the IGMP report. And after a certain brief period, they will then remove you from the multicast group if you haven't responded with a IGMP leave, right? So I think this router takes a bit more time, or there is a problem in my, no, it's done. So we've stopped receiving the multicast traffic, which means the IGMP leave has been processed and we've been removed from the multicast group. Okay, so I'm gonna skip the questions and we'll keep questions to the end, and I'll run through the other slides. Okay. So the topology that we've seen in these tests is you have a tester, which is Ostinato, which is connected to the DUT. For the basic tests, we had only one link. We sent something and received something on that link. For the scenario test, the routing test, IMIX and multicast, we had 2 ports on the tester. We sent traffic from one and received from the other. Of course, you could have bidirectional traffic also. You could have more links also. The point I was trying to make here is you can have various kinds of topologies. But before we go to topologies, this tester block, which is Ostinato, looks like one software or one component. In reality, it is actually made of 2 different components. So you have the controller, which is the GUI app that you see, and this is where you configure and control and where you see the results. There's another process running in the background, which is the agent called drone. This does all the heavy lifting. This does the actual packet generation, packet capture, the emulation, the statistics, and everything. So the controller controls the agent via a protobuf-based RPC mechanism. So when you start Ostinato, both the controller and agent start. And that's why you don't realize that there are actually 2 different components. But what this architecture enables us to do is we can have a topology like this. You can have multiple drone agents running on other servers, not just on the same machine. You can run it on several different servers, and using one GUI, you can connect to all of them and configure, control them from a single pane of glass, right? Uh, let me quickly show you what I mean by that. So let's stop this. So right now, this is my Windows development machine where this port group, which is 127.0.0.1, which lists all the ports which are on this particular host. Now, if I have another Mac running where I also have a drone running. So if I want to connect to that, I say new port group. I give that IP address. It comes up here, but it doesn't show it because I've not reserved any ports there. So now this port group 0 was my local port group. Port group 1 is on a remote host, which has these local interfaces, but you can operate on them just like you did on your local. So you can control everything together from one GUI. Right? And as I said, all of these can be running on different operating systems. You don't need all of them to be running on the same. Plus, you could also have multiple GUIs connect to the same drone. For example, if you have multiple ports on drone, you can share them and multiple GUIs can connect to the same drone. So the controller doesn't need to be just this GUI. A Python API is also available for you to do scripting and automation and stuff like that. Yeah, so someone asked about performance. So this is an indicative performance. On the left table there is for a 1 gig interface. We reach about close to line rate for 128 byte packets. And as all of you are packet heads, you know, is typically for these kinds of applications is the small packet size, which will have the least performance because these applications are typically PPS. PPS is what matters more to them rather than MBPS. So the small packet byte performance is not very good. On the right side is a 40 gig interface. Again, the maximum that we can reach for the larger packet sizes are about 18 or 16 gig. These are the jumbo frames. Again, packets performance for the smaller packet size is not very good. So these numbers are using Ostinato for Linux. Don't use Ostinato for Windows on for performance measurements because it's an order of magnitude less than on Linux, possibly due to WinPcap or NPCap issues or the driver or Windows OS itself. So if you're doing any performance tests, you should always use Ostinato for Linux. Also, I'm currently working on something I'm calling Turbo Transmit. This is 64-bit line rate support for 10, 25, 40 gig NICs. I'm using AF XDP for this, and the prototyping results have been quite promising. Using a single CPU core on the XL710 40 gig interface, I can get about 22 million packets per second, which is about 15 gigs of traffic. And in comparison, if you look at the Pcap results that I just showed you, that's about 0.755 Mbps, right? So 64 byte performance, 22 million packets per second means with one core, you can fill a 10 gig pipe. With 2 cores, you can fill 25 gig pipe. And with 3 cores, you can fill a 40 gig pipe. Well, that's the theory. I'm still working on the code. And if you want to be updated on the progress and get access to the early version of the code, that's the URL you go to sign up to get updates and get into the early access list. Finally, some caveats. So like Wireshark, Ostinato is a professional tool, and the problem with every professional tool is there is a bit of a learning curve. It's always a challenge from a UI UX perspective to address both experts in expert audiences and beginners with the same tool and the same UI UX. So that's a challenge, and I'm working on those, and feedback and suggestions are always welcome. So one thing that I do always say is Ostinato is a tool. You are the brains. So you need to know what kind of packets you want to generate. Ostinato can generate the packet that you want, but you need to know exactly what kind of packets you want to generate. You want to know, for example, if you want to send SIP traffic, you need to know that SIP is UDP. So I need to select UDP. Then you need to know what UDP protocol numbers you need to set for SIP and stuff like that. So it's the same garbage in, garbage out principle, because sometimes people contact me saying, I sent this packet and it's not working, but then they've configured something incorrect. So it always helps to check your work. Okay, so that finishes my presentation, and we'll go good on right on time. So Chris, let's address all the remaining questions.
Okay, sounds good. Good job with the presentation. So let's go ahead and take a look at this one. How difficult would you say is it for a developer not familiar with Ostinato code to add support for custom protocols instead of having to edit their fields via hex dump?
Sure. So there are three ways you can add custom protocols. One is the hex dump, which is of course not a very intuitive way. The second is something called script. So a JavaScript like language is available through which you can write a custom protocol, and the documentation gives you details and examples about that. Now, again, the JavaScript like thing is directly done in the GUI, so you don't actually have to go to the source code. But if you really want to go to the source code and you want to have that nice GUI like thing and have packet fields and have a GUI for those, you need to go to the C++ source code. There is like the Wireshark dissector framework, where there is a framework where you can add new dissectors. Ostinato also has a protocol builder framework. Again, there is documentation available for it. You can use that to develop custom protocols, or even protocols that are not yet supported by Ostinato.
Okay. Good. How about what's the minimum memory CPU for Ostinato to run effectively?
Oh, it depends. Now the answer, like everything, is depends, but it runs very well on. For example, you can run it at a 500 meg VM, or even less number of VM. Actually, it doesn't need much. So I've never looked at what is the bare minimum. Today's computers are beefy enough for those, or even VMs, you don't need to provision much vCPU or memory to it. It runs very well. It doesn't actually take much CPU. So the trick there is that the CPU is essentially used during transmit time. We don't build packets on the fly. So when you actually click on apply, what happens in the background is that we pre-build all the packets that we are going to send. So there is some algorithm there to determine the minimum number of unique packets, and it builds those packets. And then when you hit on transmit, the whole full CPU is used to just transmit those already pre-built packets.
Okay, thank you. Is there any kind of authentication or encryption between the controller and the drone?
No, so you have the assumption right now is both of them are within your perimeter, and you don't need any authentication or some kind of encryption. So right now it's open, and you should not run these across networks.
Okay, good. So there was a question earlier about correlating packets in, packets out.
Mm-hmm.
So there's this additional detail about that question. So regarding correlation, do packets contain, or can they contain, some ID that Ostinato knows that it's created by it?
So you can, let me open up Ostinato. So you can use that. Let me delete this port group. No, what was the last one that we used? Okay. So here you have something called signature. So typically we use this signature when you want to send identify stream IDs, right? So if once I click signature here, if you go to protocol data, you see a signature appear here. So you can give a number to that. And when you have multiple streams, if you give unique numbers, you can identify that this particular packet belongs to this stream so that you can do per stream statistics. So that is one way you can identify that this is actually generated by Ostinato.
Okay, nice job. So we asked this one earlier. I just want to make sure that we answered it. Do you have a server-side agent so we can quantify packet loss for VoIP and video-enabled networks?
Okay, so when you say server, it's Ostinato is not a client iPerf-like client server scenario. It just sends packet. So the agent controller is not like a client server. So there is no server that side that is going to reply back, or at least Ostinato doesn't have a server side component that is going to reply on that. I don't know if I answered that question correctly. I mean, I'm not sure if I understood the question correctly for that matter.
If Adrian was the asker, if he's still out there and needs any more detail, let us know. Otherwise, we'll assume that one's been answered for him.
Right. Otherwise, reach out to me on Discord. I'm around, and we can discuss.
Yeah, maybe. Yeah, okay. So you don't mind hanging out in Discord after this? And
No, I'm around on Discord.
Okay. So we'll see you guys in Zoom room 1, unless there's any other questions that we can answer right here on the webinar. Oh, Adrian came back with this. Let me rephrase. When the destination side receives packets generated from the source client, can you determine QoS markings, packet loss, etc.?
Yeah. Okay. So what you need to do if you want to do that is typically you should keep Ostinato as the destination side as well. As in, for example, let me go back to this slide. Right. This right side topology, configure your topology in a way that both the source and destination are links on Ostinato. And when you do that, you can then monitor number of packets that you've sent out from Ostinato, number of packets that you have received on Ostinato, and you can do that DSCP analysis and all. So I mean, for each stream, you'll be able to get statistics, and you'll know how much packet drop has happened on each stream. For example, a higher priority packet stream should not have drops, and lower priority packet should have drops, and so on. So to do that analysis, you should set up your topology such that both the source and destination are links terminating on Ostinato. So please do fill out the speaker survey. And if there are any more questions, I can answer. Otherwise, I'm on Discord, and you can reach me out there, and we can discuss more on whatever you want to know about.